we have a full stream prepared for today. So right now I actually have the question and answer screen up, but I do want the stock market screen up just temporarily so I can show you guys the current um, contestants trends page. So you can see that although we did see a rather uh, significant spike from Dan and Khalil, you can see that with the markets recent change, both of them have gone down at, I believe that is exactly the same slope. That's due to the fact that both 12 and Blue did not receive any votes last week. So if we go back to the scoreboard, you can see that Khalil and Dan both only invested in Blue and 12. Dan's case, he only invested in 12. So that means that that is what we're seeing. They have received the exact same downwards trend. Although you can see that I have barely snuck past Dan and also have reached my all-time high. Um, and we can see that we're starting to see somewhat of a division between the top three here and the middle of the pack. Although the middle of the pack seems to be changing places relatively frequently, we are seeing that Khalil, Dan, and myself have put somewhat of a distance between us and the rest of the pack. And you can also see that for the first time in a very long time, in fact, since the beginning of the season, even Steven is now above that 100,000 point. And you can also see that Megan has gone down a little bit in the past week. So I think it's an interesting trend that we're seeing. I've also added in these areas down here. This is just an exact replica of the first two columns of the contestants trends page, or of the scoreboard page. And what that should be able to do is allow me to just copy and paste them fairly quickly into their respective columns in the actual stock market videos. So maybe we can do that from now on. We'll see how it goes in the next one. But that is the current state of the stock market. I did receive a couple text messages, just making sure it's not about the stream. It is not. So that is where we are for the stock market, and I am going to switch back over to the question and answers page. And the reason that I'm doing that is actually because I wanted to talk a little bit about Florida waterbirds. So this is something that a couple of my friends realized was something I just oddly know a lot about. To give you some context, for one, live in Florida. I lived on a river, and I also, when I was younger, went to a lot of marine science camps. So what I learned from there is oddly a lot about birds. But because we do have a lot of different types of birds here in Florida, and a lot of interestingly sized birds, per se, if you go up into the northern areas, there tends to be a lot of tree-dwelling birds, the smaller birds. But here in Florida, we have a lot of larger birds. So today we're going to talk about a set of medium-sized birds. And so what we are going to be talking about is snake birds. And so this is not to be confused with shriveled up snake women. These are snake birds. And this is a category of bird that makes you ask the question, why is that water moccasin out of the water like it were a cobra on land? And that is because it is not actually a water moccasin, it is a snake bird, where most of the bird is submerged underwater. So we see this situation where there will be some sort of snake-looking creature out of the water like this, but that is because there is actually an entire bird underneath. And so this is obviously a theoretical blob representation of our snake bird, because we're going to be getting into a little bit more of the specifics of the actual snake birds themselves. So along the way, if you guys have any questions about anything specific you're seeing on the screen, then please feel free to leave those in the chat. I will be watching that. But yeah, I'm going to get rid of this picture. And we're going to be talking about two different birds. So in Florida, when we talk about snake birds, there are two that really come up, and the problem is they're very similar in their actual behaviors. So let's talk about the similarities first. So things you might see this snake bird doing. So if we redraw our first picture, then you can see category one, what I would like to call the Loch Ness monster. The snake birds will swim with their head above the water, like so. So this is just a theoretical bird. It's not either of our two. So category two. In Florida, we have a lot of man-made retention ponds. So if you have a pond here, what will happen is these retention ponds are set up as a drainage system for a lot of the surrounding area if you have like a neighborhood. And what will be there is there will actually be this kind of like pump box. I'm not sure if this is actually where the water is coming in or whether this is where the water is going out to some other drainage system to keep it from hitting some level. That seems pretty reasonable. But what you'll actually see is you'll a lot of times see birds here with their wings out like so, and they will just be sitting there, kind of just taking it in. And the reason for this is in order for a bird to fly, they must be fairly light. And when a bird is wet, they are not as light because their feathers have soaked in that water. So these birds actually will sit on these metal contraptions and dry their wings. Now I do see a question in the chat. It says, and this is Leon asking, how long do you intend the stock market seasons to be going? Are you planning on adding any more features as time goes on? So the stock markets, according to the precedent set by the first season, are going about 26 weeks, which is half a year. So we are, I believe, in week 14, if I remember correctly. Actually, yes, I think that is correct. So we are in week 14. And so that means we are a little over halfway through this season, and I probably won't add any new features until the next season, if that answers your question. So these are two relatively normal cases, and then also this is pretty common for a lot of water birds, but you'll see them just kind of sitting on these disappearing islands. Oh, actually, no. So what you'll see is there'll be a lot of dead trees along the river, and so the water birds, in a similar fashion to these retention pond situations, they will actually stand along at the top of these dead trees, whether they be dead palm trees or I believe there's also mangroves that will get pretty large and then dry up. They tend to like to stand at the top of these mangrove trees. So I'm hoping that if you have experienced any of the Florida water birds, these situations may be ringing a bell for what birds I am referring to. So this is situation 3. And so these are the pretty common situations that you may see these birds in. Now, if I'm missing any and those in the chat wish to share those with me, I will add them to the list here. But for now, we are going to move on to actually deciphering between the two very common snake birds. So let's get a new picture here. And we are going to split this down the middle. We're going to create a T-chart here. So what we want to look at here is first we are looking at the anhinga, and I want to make sure I'm spelling this correctly. Anhinga, and if I go check out, yes, I have spelled that correctly. So this is the anhinga, and this is actually a fairly well-known bird amongst the snake birds. I would say of the two, most people will be able to spout out the word anhinga before they will spout out our second bird here. But we're going to focus on the anhinga for a moment. Now, the real big difference between these two birds is their actual head. The rest of their body is fairly similar, but we'll show a little bit more differences. So the Anhinga is, if we start to draw their head like so, they have this very sharp beak, and then their head actually, I haven't done it justice. So their head is actually quite flat on the bottom, and they have small beady eyes. And so, like I said, they have this long, sharp beak, and this beak is actually used to pierce fish while underwater, so that they can be consumed later. So this is our Anhinga. They are relatively round-topped on the head, and they are fairly streamlined. So this would be, if we were comparing it to some sort of Chevrolet car, this would be your Corvette. I don't even know if I spelled Corvette right, but there we go. I don't own a Corvette, so I don't know how to spell it. And this is a V, and this is an R, for those of you that may be confused. So the Anhinga is streamlined with a sharp beak. And they also have sort of a smoky, dark brown texture to them. So these are the features that are associated with an Anhinga. So if we go to our second bird here, our second bird is actually a cormorant. Cormorant. There we go. And so there are actually a lot of similar features about this. They are about the same size. They are about their behaviors, as previously mentioned, are very similar. They are also a dark brown, but they are actually a glossy brown. But we're going to show you the actual head shape. So if we draw this, I want to try and be accurate to the actual size. Now they have, I believe they have somewhat larger eyes, or at least more noticeable, yes. So I'll try and make that apparent. And they also, one of their defining features is their beak. So Anhingas, although both of them can have somewhat yellow beaks, the cormorants tend to have more significantly standing out beaks, and they also have this this kind of falcon-shaped downwards curve to their beak. I believe this is better in terms of keeping things in your mouth. If I had to guess things, if I had to guess the actual evolutionary purpose, they also tend to have some little tufts on the top of their head here. But those, once wet, are not as noticeable. The Anhinga tends to be a little bit more streamlined, as previously mentioned. But the rest of their body is fairly similar, although they tend to be a little bit more round-bellied compared to the Anhinga. So that would be the cormorant, and this would be the Anhinga. So I guess this kind of gives them a more cartoony look if you're trying to get an idea of this. And they also, so if this were going with our Chevrolet idea, then this would be your Camaro. It's the I guess kind of the muscle car build of the snakebird family. So, as I mentioned, they are a little bit bulkier. They're about the same height. They have a curved beak. And they also are a glossy dark brown. And they are a little bit darker. So, glossy dark brown. So that is pretty much it for the snake birds. So these are two very common birds, but I feel like a lot of people will see them and not necessarily decipher the difference. They'll just say, "Oh, that's one of those snake birds," but it's actually two different, completely different species. So, um, well, they may be cousins or something. I don't know. I haven't done too much actual biological research. This is just my own experience from living in Florida and going out and experiencing the wild. So I hope that you have learned something from this talk here, and we are actually going to be moving on to a talk about my AI. So I am going to clean this up, but I hope you are enjoying. If you have any questions about this section and you want to ask those before I move on to the next, I'm going to be cleaning stuff up, so go ahead and post those in the chat, and I will make sure to cover them before I move on to the next section. All right, we're going to get into the next section here, and once again, if you have any questions, I'll still answer them. I just may wait until the end of the section to actually answer them. So we're going to be talking about my new for me setup for my neural network. So in the past, I've talked about the fishbowl neural network idea, and this is a name that I've given it. I don't know if it's out there already being used in some sense, but and so what I've done is I've begun the coding process, I believe for the third time, but I just keep restarting and trying to perfect the actual concept of it before I get into the nitty-gritty of actually implementing it. So I want to show you kind of the design of this, and I have talked about the fishbowl neural network in the past. I'll probably put a link up to a previous talk so you can get an idea of the actual concept behind it. But essentially, it's something that takes in analog inputs, or sorry, binary inputs, and spits out binary outputs. And what is special about it is it's not necessarily your normal setup for neural networks. So it's not your normal progression through the layers. The idea is that these connections can be to any different node. So you can go backwards, you can go forwards, and the beauty of this is it actually allows the AI to set up its own logic. So the AI can create sort of a computer that is built to either hold information, process information, or react fairly quickly based off of some instinctual measure. So that is the idea. There's some interesting concepts. I'll go through a couple of them just real quick. I mentioned that the AI will be able to hold on to information, and the way that it can do this is, so let's say we have these nodes in this kind of pattern, and so this is our input, this is our output, and we have a loop like so. Well, what this can do is, so the way that this works is, say this one is ready to fire. So this one is highlighted. So it has a connection to this node here. The way that it does this, so it can fire, and when it does fire, it flips all of its connections. So these nodes can either be a 1 or a -1. -1 is off, 1 is on. Now I could do 0 or 1. The reason that I'm doing this is it's fairly easy to flip the current value just by multiplying by -1. So that's important. When this node fires, it will ignite this node. So then this node will fire, ignite this one, and when they ignite, they turn themselves off. So we're gonna put a big slash through there. Um, and so then this one fires, ignites this node. I think you get the pattern, so I'm just gonna kind of skip ahead. So here is where it's gonna get interesting. So we're gonna cross that guy out. And so for here, this node is going to have two different connections, like so. So what it's doing is it's feeding the information that it currently has on, but it's also feeding this information into this loop, like so. And when it gets back to here, then if this node is no longer firing, then this loop will perpetually continually push that information on. Now, what can happen is if this node fires again at the same time that this guy right here fires, then this node will be flipped on and then off, ending the loop. So there's some possible logic here, and I think that's a fairly interesting concept. Now, I won't necessarily be able to visualize this. I was hoping that I would be able to set it up in some sort of visual representation so that it would be nice to see these firing, but because there's going to be a lot of randomness as to where specific nodes are connected, I didn't think that the visual representation would actually give us any big insight. It would just kind of be there, taking up space. So I wanted to focus on getting the actual logic down, implementing it into what I'm planning to just implement it flatline into the environment project to see if that will actually amplify the results of that. But it may be a situation, because of the way it's set up, where I need to run it in a game where it just has to go in a straight line, and then run it in a game where it has to spin around and line up with a target, and then combine those activities into a situation where it has to go and turn in the process. And because of the way it's set up, it will have this structure, this data structure set up so that it can be moved from one task to the other and still have the previous data structure to work with. But I think that I'm going to focus on the just letting it loose on the previous task and seeing if it works well, and that's where we're going to go. So let me get into the actual structure that I am thinking of for the code itself. So first off, we have our fishbowl neural network, right? And so what we're going to do is this is the neural network, and it's going to be running some simulation inside. So this is going to be our sim. This is going to be our fishbowl neural network. And so this is some loop inside here that is constantly running the game that it's playing. And it's taking in inputs, feeding it through its own system, and spitting out outputs that will create decisions in the game, whether it goes straight, whether it turns on a flashlight, something like that. And so then we're going to have this outer loop from here that's going to be somewhat larger. So in this outer loop, there is going to be a secondary feature here. So this is going to be the mutation. So this mutation is an evolutionary system. So if you've seen way back when, an evolutionary system is actually a system where it tries new traits, and if those traits produce a better result than the previous traits, then those propagate onto the next generation. Now, this won't necessarily be genetic in a sense, because I'm not necessarily kind of. It's going to be a singular parent genetic, so there won't be two possible uh, points where it's creating mutations from, these mutations will all be based off of the current situation and just trying to make tiny tweaks to it. Um, so it will be allowed to make a certain amount of changes, and those changes will have probabilities based off of what it will have probabilities to decide which ones are actually going to um, are going to be changes. So then we need to decide what those numbers are going to be. So the probabilities of specific changes, whether they be creating a new connection, deleting an old connection, creating a new node, something like that. We need to decide which of these, what are going to be those values. So what I decided that what was going to happen is there's going to be a larger loop outside of here, and this is going to be a regular classical neural network. Now it will be so it's not necessarily a neural network. It's steepest descent optimization. So this is going to be our value optimization. And the reason that this is important is because an evolutionary system is actually quite inefficient. It will try a lot of the same things over and over and over again. And the reason that I want to have this system is because I don't know what the best values are for how many mutations should happen every generation, how many different changes it should try, and what kind of changes are important. And that might be a dynamic question. It's not necessarily something that I can set values for right at the beginning and just allow it to run free and it will just work until it's perfect. And there's a lot of things in AI where if you don't set it up correctly, it will reach exhaustion at a point you're not necessarily satisfied with. So I want there to be this option for when it is not necessarily making as much progress, it can try to change the way that it's making progress. And that's what this value optimization is for. It's going to be changing these possible mutations and the probability of those mutations happening. So what it can change is the sorry, I have it up on my whiteboard over here, so I might be looking back there. It can change the number of mutations, not an H, a pound sign. The number of mutations. It can change the probabilities of those mutations. So I'm going to put a percentage times 3, I guess, because there's the adding a connection, deleting a connection, and adding a node. I don't want it to be able to delete nodes. I think that would be detrimental. It could just reuse those nodes by adding or deleting. So I think that the more nodes available, the more potential for actual propagation of logic. I'm seeing a question: what kickstarted your fascination with AI? I kind of had it on my mind just in general. I mean AI is pretty cool as a concept, but one thing that really kind of got me interested was I actually watched Seth Bling's coverage of there was a team that made an AI for Mario, and I believe it was like mar.io. And what they did was they made a neural network that actually would just live in the Mario world, in the two-dimensional old Mario 64 world. And what it would do is it was getting rewards from picking up coins and jumping on Goombas and stuff. And it basically learned how to survive in the world, not necessarily playing the game, but just kind of surviving. And I think that kind of propagates into what I'm focused on now. Is I want to create something that can sort of just receive a fitness score and create its own goals and go explore new possible ways to play in an environment um, that I set up. So I think that that is a lot of the inspiration that I got. So this is kind of the setup. I had a lot more loops in this before, and then I ended up dwindling it down to just this propagation. Now, there is still three loops. There's the simulation cycles, and those cycle through the actual fishbowl neural network. This is much like if we had a regular neural network, it would be using that to create um, make decisions in real time. And then these mutations are happening in the background. So it'll be testing new ideas. The way that it's going to do this is actually going to split off, and so the first half of this, per se, is going to be testing the old ideas. So this is going to be the old ones. And then in the second half of the cycle, it's going to test the new ideas. And so it's going to, it's going to test each change, and see if that makes a benefit. Well, that's not necessarily true. So it may be better to test a bunch of changes at once. In an evolutionary system, you usually allow it to create a bunch of mutations and then go check to see if those mutations were beneficial. The problem with this is it can allow for propagation of negative mutations, but hopefully later on those mutations will be worked out of the way because better ideas will come along. Now, this also kind of brings up the possibility that the AI could regress to a worse state. Say the AI was really good at going straight in a straight line, and it gets some new idea that it can I don't know, it knows how to turn the flashlight on now, but if it learns how to turn on the flashlight at the expense of going straight, that could be detrimental. But that's something I'm hoping will work itself out in a little bit. But I kind of want to get it running first before I start tweaking things. So it tests the old version to get a datum in the current situation, because in real time, you may have Jeffrey here, and maybe there's a rock here, and there's a piece of food on the other side, and Jeffrey wants his score to go up. So in this current situation, it will test the old instincts to see if that creates a benefit in score, and then it will also then after that it will take whatever the last score it had with the old one and use that as a datum for testing the new one. And so I'm not actually testing based off of raw score. I'm testing off of improvement. So I want the AI to be trying to learn how to make its score go up at the highest rate. I think that's a better idea because of the way that the game's set up. I'm trying to what am I thinking? Motivate exploration. So I want the AI to go further. And if you have seen any of the Environment Project videos, you will know that there is, in the fitness score, the AI earns a higher score if it leaves its home position and goes further out into the environment. Although once it's out in its environment, it starts losing battery. So that is the situation. But the AI won't necessarily know what its score is. I'm trying to think of how I'm going to implement it. So with binary inputs, I can't necessarily just feed it raw its health score and its battery score. But what I can do is I can feed them in as binary numbers. And with exponential growth in binary, it would be a decent string of numbers, but it wouldn't be that much. So if the highest health is 100, then let's see, you can get a 64 and a 32, and that'll bring you to 96, and then you just need 4 more. So you would have 1/4, 132, and 164. That's three ones. So maybe if like the 61, the 64 category is a zero, then that's a problem because a good chunk of the battery is gone. But if the 32 is a zero, that's not necessarily as much of a problem unless the 64 is also gone. So I think that's an interesting way to implement it, and I'm going to see how it works out. But I have had problems in the past with AI sifting through data. Now, there won't necessarily be as much data because I'm boiling everything down into binary inputs. So hopefully it won't be nearly as much of a problem as when I were, say, implementing the cite feature in Sell Me Something, because I was in Sell Me Something, the AI could see its surroundings, but when I implemented it with a very large radius for that, one, it slowed down the game tremendously, so that was problematic. But two, the AI couldn't necessarily figure out how to navigate because it was looking at too much. So one thing that I'm planning to do with Jeffrey here is there's a couple things that Jeffrey had in the environment project. And so the environment, let me clear the screen. We'll kind of just talk about that for a little bit. So Jeffrey had two things he could do in the environment project. Oh, two. I don't know where I got two from. So he has his radar. He has his flashlight. He has his sprint. And then he has like move times 4. Oh, well, no, it's actually just move times 1, and then rotate. So, with these situations, now rotate we might have times 2 or something like that, just because we want him to be able to move in either direction, as opposed to having to turn all the way around to get into the direction that he wants. Um, so with the radar will let you know if something is on the screen. So it's wide range, but it's not very intuitive. It's not very intelligent. So it just gives you an idea if something's there. So there's something. Now the flashlight is more enlightening. No pun intended. Well, pun intended actually. It's local, so it's a local area around Jeffrey, but it tells you what's there. So I'm working out um, how to categorize this. So specific. I'm thinking that what I will do is set up sort of a bundle of inputs that have to do specifically with the radar and the flashlight. And also, what I'm thinking is I'm going to boil this down to 8 things. So if there's more than 8 things on the screen, Jeffrey won't necessarily know about that ninth thing. Um, and what I'm going to use as the deciding factor of what is known and what isn't is proximity. So Jeffrey will focus on the things that are close to him, just so we're not getting too much data in. So with this flashlight bundle of inputs, you will have maybe um, a option of the possible things that it could be. So it could be food, it could be an obstruction, or it could be an enemy. Those are pretty much the only 3 things that you can have in the environment project. And so whichever one it is will just have a big, it'll have a positive 1 there as opposed to a negative 1. Um, and then it will also have the proximity. So the proximity will have to be something that is a string of binary numbers, well, one binary number, but it will be a string of either negative ones or ones, to decipher what that number actually is, and obviously it will have to be brought to an integer. Um, and then we also have to give the direction. Now the direction is going to be a little bit trickier. I may be able to do binary with actual degrees, and that could be what we want, but that might get a little too complex. I'm worried about that being too complex because um, if we have something like, let's say, if we're talking in binary, then we have like 32 degrees, and then we have um, 96 degrees. Both of those fire the 32 bit or byte, or I don't know which one's the actual just small one. But they so if Jeffrey were to be making a decision based specifically off of the 32 and not the 64, then there's a big difference between 96 degrees and 32. The hope is that eventually all of these will be accounted for, and that's not a problem. But it's going to take a lot of logic, and so I'm curious to see how it actually plays out. I kind of want to make it too complex to begin with, just to see if this system can handle it, and then try and boil it down to an easier input. Because part of the problem with a survival in an environment is actually the assets you have at your disposal. And since Jeffrey can't necessarily change what assets he has other than turning them on and off, um, he can't make he can't necessarily improve himself in that situation. He can only use his assets better. So if I give him something that is a poor asset, then that's not that's on me. That's not on the actual program itself. So yeah, I think that's how it's going to be done. Is that the information is going to be put in. So there'll be like 8 chunks of this, which will probably all be negative ones until there's actually 8 things on the screen. And then for the radar, it'll probably be the same thing. There'll be 8 of those. And Jeffrey will be able to focus on those 8 things. So with the radar, you won't need this first section, so that won't be necessary, because all Jeffrey needs to know, there'll just be one there that there's something there. Either that, or you don't even need that, because all of these will be some different value. They won't propagate. If that's actually, yeah, no. So there needs to be one node that specifically says there's something here. Because if these are zeros, that's the same as saying that something's right on top of him, and that could be problematic if he were making decisions based off that. So that's pretty much where we're getting at. I think that's pretty much all I want to talk about for the Fishbowl Neural Network project. I'm planning on working on that significantly more in the days to come. I'm not going to make any promises on how soon that will be out, but I have made significant progress on the actual coding of that, so I'll keep you guys updated on that. So I need to switch over, and we're going to do the actual random drawing section. So let me get that set up. Alright, and I'm noticing we did not cross these out from last time. That was the government. It was alert, and it was cleverly. Alright, so we are going to have our random drawing section. I have the random number generator up. I'm going to, hold on, let me get this to 25. I still had it on 40 from yesterday. Alright, and if I hit enter, we're going to see our first number. That is 18. That is bra. I will remind you that my girlfriend and her sister were the people who made these words. That is 23. 23 for our verb has been used already. Our second choice is 13. 13 is croak. Alright, and our final selection is, oh, I should not have had 0 as an option, but we will fix that. Um, so if we go to 1 through 25, that is 18. 18 is cuddly. So I think this is pretty um, pretty easy to work with. Whether it'll get flagged on YouTube as unmonetized is a completely different question, but live and learn, I guess. So, um, we're going to have our non-racially specific gray person, and I don't know what that is. So yeah, let's just focus on um, the actual device of question. So, there are a couple different ways we could interpret the word croak. Whether this is when someone says that someone croaked, that usually means that they are no longer with us. But in this case, we're saying that it is a bra and it is cuddly. So maybe we can have a couple different um, meanings of the word. So if we have a very, very cute little frog, maybe like a tree frog, and we are drawing this out. Um, Fun fact, tree frogs, when they are rubbing their stomach actually secretes a mucus that is somewhat like a sunscreen for them. So they are actually protecting their body with a fluid that is created on their body. Now, this tree frog, I'm going to draw it like so. Oh, I didn't want to do undo. I wanted to grab the paint bucket. And then we're going to get a nice little mouth there. Now, as I mentioned, they do have this nice little stomach area. And I'll try and color this in like that. That makes everything not visible, so I'm trying to finish that off. Maybe I can color this in first. There we go. And then kind of looks like a turtle right now, but it's fine. Let me just get a darker color of that for the mouth. And the nose. And then we need to actually add in the bra. So to stand out, we're going to make it a purple bra. Don't know why I said it that way, but the frog has selected its gender, I guess, or I guess you don't have to in order to wear a bra. You can do whatever you want. But it is now looking for some extra support while jumping from tree to tree, as tree frogs do. So there we go. Now I just need to color that section in, and we will finish it off here. Now, I'm hoping that this is cuddly enough, and I'm hoping that this is cuddly enough to the point where you will be sad when I add the next portion of the picture in, because this frog has actually croaked. So there is going to be some sort of misty frog spirit ghost ascending from the body here. So if I color that in, then we can get some misty frog eyes. And I don't think the frog would be very happy if this were happening. Um, but you know, life is life, and that's what life is. So maybe it shouldn't crawl into small car door cracks, um, trying to avoid the rain if it wants to not be squished. Sharon. So that is not finished off there. There we go. So maybe a little bit more vision over there. But that is our tree frog. So I hope that this was enlightening on how a frog could wear a bra. And I hope that you guys enjoyed the entire stream. We did have a full stream today, almost an hour. So if you have any questions about anything that has been mentioned, please feel free to leave those in the comments of this video, and I will get to them. I'm planning on probably doing some more sections of this Florida Waterbirds talk, just because I want to make sure that I can cover adequately the frequently asked questions in the Florida Waterbird culture. Whether that be, what is that white bird in that tree, or why is that bird so big, and things like that. So I think that it's what the people want, and I'm gonna try and give the people what they want. I'm gonna be signing off. I don't know if there's gonna be anything tomorrow. Probably not, just because I haven't organized it already, and I have a concert I'm going to, and hopefully we will have a cover on Tuesday. But it's kind of just if I can get something that I feel like I am confident in performing. I don't want to sell anything short here on the channel. So that's going to be it. Thank you guys for watching, and thank you, Leon, for asking questions in the chat. It's always nice to have some participation. But until Tuesday or the next time I stream, I am going to be signing off. So goodbye.